By popular request, I'm going to go over basic trig function values, the coordinate values that we get. And I'm going to use those two triangles that we have. You recall the first triangle is that equilateral triangle, 60, 60, and 60. And as such, all the sides are the same. I'm going to bisect this angle. That's a terrible bisection, but pretend that it did bisect it. If this side is 1 and this side is 1, then this side will be 1/2, this will be 1/2. And this height here, I have to figure out as, well, I know that this point is on the point that this triangle represents, and you'll see it, is on the unit circle, which means that x squared plus y squared is equal to 1. This is my 1. I have this 1/2 here. I don't know what y is, but let's figure it out. 1/2 squared is 1/4 plus y squared is equal to 1. So y squared is equal to 1 minus 1/4, which is 3/4. Well, if y squared is 3/4, then y is the square root of 3/4, which is equal to the square root of 3 over 2. So this height here is the square root of 3 over 2. Let's remember that. I'm going to erase this and now do the second triangle, which is the 45-45 triangle. 45, 45, 90. I'm interested in this triangle because if these angles are the same, you may remember from geometry that these sides are the same as well. But I don't know what they are. They're just x and y. But I know this. They're the same. If I know that x squared plus y squared is equal to 1, which is true for this situation, then I'm going to substitute x equal to y, and I'm going to get x squared plus x squared is equal to 1. I've got two of these guys, so I'm going to write it like that. 2x squared is equal to 1. That means that x squared is equal to 1/2. And that means that x is equal to the square root of 1/2, which is 1 over the square root of 2. So that means that this number here, x is equal to 1 over the square root of 2, and this number here, y is equal to 1 over the square root of 2. I'm going to remember that now when I go to my unit circles, which I will now erase this. And now let's draw the unit circle. My first point, t is equal to 0. I put that there. And I know that my coordinate pair there is x is 1, and y doesn't go anywhere up or down, so my coordinate pair is 1, 0. And it's true, it satisfies. 1 squared plus 0 squared is equal to 1. So it works. My x coordinate is 1. My y coordinate is 0. What is my cosine? You may recall that I defined, when we were talking about the cosine of t, I said the cosine of t was the x coordinate, and the sine of t was that y coordinate. And so I very simply, if I have a 1 here, I'm going to have a 1 here, because cosine of t is x. Sine of t is y. Now let's do pi over 6. Pi, you recall, goes all the way around. Pi sixths goes 1/6 of the way. This is my point. Let's erase this now. This is my point for pi sixths. I'm going to draw this little triangle here, and I recognize that, aha, these are the triangles I'm looking at right here. I have to flip it a little bit, but basically that triangle is right there. My height, I've already figured, is 1/2. You're gonna have to mentally rotate and flip this triangle around so that it works. But that height is 1/2, and this x-coordinate is square root of 3 over 2. So here we go. Square root of 3 over 2 is my x. 1/2 is my y. Square root of 3 over 2 is my cosine. 1/2 is my sine. Gonna change things up now. And I'm going to go to pi fourths. Remember, pi is all the way to there. Pi halves is right there. Pi fourths is right there. That's going to be this triangle here. That's going to go in there. That means my x-coordinate is 1 over the square root of 2. My y-coordinate is 1 over the square root of 2. So my x is 1 over the square root of 2. Y is 1 over the square root of 2. Cosine is the same as my x. Sine is the same as my y. And that is how you are to do the rest of the table. That same, what triangle goes where, what are my x and y values for that point t, and then translate it to cosine and sine values for that point t. The cosine is x, the sine is y.